This is video number 8 for chapter 7, and in this video we are going to teach you what an empirical formula is and how to calculate the empirical formula for a compound. So first of all, what is an empirical formula? Well, empirical formula is just the simplest ratio of the elements in a compound. Okay, so if we take an example like glucose. Glucose has a formula C6H12O6. That's its molecular formula. Now the molecular formula is its actual formula. We know that glucose actually has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. But if we were going to reduce that to an empirical formula, or its simplest ratio, you'll notice that the subscripts 6, 12, and 6 are all divisible by 2. So we can reduce that. In fact, they're all divisible by 6 as well. So we can reduce this to CH2O. And so that is what we would call the empirical formula. That's its simplest ratio. Now, in some cases, the molecular formula is also the empirical formula. An example where that would be true would be water. H2O, we know as a molecule, really does have 2 hydrogen atoms and 1 oxygen atom. So this is both its molecular formula, because that's what it actually is, but if you try to reduce that any further, there's no way to do so. So that is also its empirical formula. So hopefully now you understand the difference between a molecular formula and an empirical formula. Now, when we ask you to calculate these, we're going to ask you to follow 3 pretty simple steps. All of the steps you know how to do already. So it's now just putting them together. We're going to take whatever we're given, whether it's in grams or percentages, and we're going to change that to moles. We're going to convert them to moles for every element in the compound. Then we're going to compare all those moles we just calculated by dividing each one of them by the smallest number of moles that we got. And then lastly, we're going to use those ratios that we got in number 2 as our subscripts in writing the formula. Now, when we actually put this into practice, you're going to see that this is a pretty easy process to do. So in your paper or in your packet, you're going to see here that we have a practice problem. It says to determine the empirical formula for a compound containing 2.128 grams of chlorine and 1.203 grams of calcium. So we're going to start by writing down our givens. The first was 2.128 grams of chlorine. And the second one is 1.203 grams of calcium. Now, if you look at your first step, the first step says to change the givens to moles. So you're going to want your periodic table out, and you're going to find the number of grams that are in a mole of chlorine. So if you remember factor label method, the unit we're trying to get rid of is going to go on the bottom. The unit we're trying to convert it to is going to go on the top. And we know that 1 mole, according to our periodic table, has 35.45 grams of chlorine. And so what I would like you to do is use your calculators to figure out exactly what that number should be. Keeping in mind we should keep 4 significant digits. These zeros don't count, so your answer should be 6.06003 moles of Cl. Now you're going to do exactly the same thing for the calcium. So you're going to take it and change it into moles of calcium by getting rid of grams of calcium. You're going to use your periodic table to look up what 1 mole weighs. You're going to find that it's 40.08 grams. And when you do this math, 1.203 divided by 40.08, you should get 0.03001 moles of calcium. So step 1 is now done. We've changed what we were given to moles. Now, in step 2, I want you to look at the 2 answers you just got, and I want you to compare them by dividing each one of these by the smallest number. Well, 0.06 is bigger than 0.03, so the smallest number is 0.03011. So obviously when we divide that, we're going to get 1. And here, when you divide this out, you get really close, exactly almost to 2. So these numbers, the 2 and the 1, will now become our subscripts in our empirical formula, meaning the CL would get a 2 and the CA would get a 1. Now it's okay to leave it like this, but most students remember that metals usually get written before nonmetals, so it'd probably be more proper to write it like this. However, I would never mark you wrong if this is how you left your answer. That's perfectly acceptable. So that's example number 1. Let's move on to example number 2. Okay, now in this example, the givens, you'll notice, are percents. 54.1% calcium, 43.2% oxygen, and 2.70% hydrogen. Now, the way you can get around having these be percents is just say, assume that we have 100 grams of the compound. Because if we have 100 grams of this compound and 54.1% of those 100 grams are calcium, then it's 54.1 grams of calcium. It's 43.2 grams of oxygen, and lastly, it's 2.70 grams of hydrogen. So once you know that you can change your percents to grams pretty easily, then the next step is to just convert all of these to moles. So you're going to use your periodic table, and you're going to look up the molar mass of each one of these. For calcium, 40.08 grams goes into 1 mole. And when you take 54.1 and divide by 40.08, you should get 1.35 moles of calcium. When you do this for hydrogen, or excuse me, for oxygen, we know that 1 mole of oxygen, according to our periodic table, is 16.00 grams. And so when we do the math of taking 43.2 divided by 16, we should get 2.70 moles of oxygen. And then our last step is to do the same thing for the hydrogen. And when we look up hydrogen on our periodic table, 1 mole of hydrogen has a molar mass of 1.01 grams. And so when we do that math, we should get 2.67 moles of hydrogen. So step 1 is the one that takes the longest, converting all of your givens to moles. If you look at step 2, it says to find the smallest number of those moles and divide everything through by it. So the smallest number is this one here. So if I take 1.35, and obviously if I divide by 1.35, I'm going to get exactly 1. If I take 2.70 and I divide by 1.35, I get exactly 2. If I take 2.67 and divide by 1.35, I'm going to get pretty darn close to 2. It's like 1.98, and so I'm going to round that to 2. These are our subscripts in our chemical formula. So I will say Ca has a subscript of 1, oxygen has a subscript of 2, and so does hydrogen. Now, there is one trick that you will have to be aware of. Once in a while, when you do your division of your moles, you won't get exactly a whole number. You might get a half, like 1.5 or 2.5. And in that case, if you were to take a number, let's say I got 3 and I divided by 2, that's going to give me 1.5. I am not going to be able to just round that up to 2. Let's say I had 2 divided by 2 as the other one. In order to get this to work, I'm going to have to clear the fraction. The fraction is a half, so I'm going to multiply everything through by 2. So this subscript would now become 3, and this subscript would become 2. So rather than having subscripts of 1.5 and 1, I will have whole number subscripts of 3 and 2. This is really only important when it's halves. You really don't see very many other options of fractions that you'd have to worry about. So now we have a learning check for you to try. You'll try that when you get to class. Good luck.